Okay, so today's lesson is going to be about how to convert a standard form to a vertex form. Okay, so again, vertex form is something that looks like this, and a standard form is something that looks like this. If you remember from grade 10, factoring perfect square trinomials, when you have a perfect square, you were able to factor it to x plus 3 times x plus 3 and get x plus 3 squared. You can do that by doing product sum factor, right? So product is 9, sum is 6, my factors will be 3 and 3, and then you just do x plus 3 and x plus 3, right? We did this in the beginning as well. Same thing over here, product is 25, sum is negative 10, my factors will be negative 5 and negative 5, and that's what I get as my answer. Okay, so let's try thinking of what constants would make the following four equations to perfect squares. So we have x squared plus 14x. What could go in that blank? 49. And how did you do that? Awesome. And then what about the next one? We have negative 4 over here. Two squared. 2 squared will be 4. So one thing to remember, this is 2 times whatever that is, 14, so it's 7, right? 7 squared will be 49. So you can do 2 times negative 2. Negative 2 whole squared is positive 4. 2 times negative 9 is negative 18. Negative 9 whole squared is 81. 2 times 2 is 4. 2 squared is, oh no, this is 2. So 2 times 1 is 2. 1 squared is 1. Make sense? Questions, confusions? Okay, let's move on. So to convert from standard form to vertex form, you have to complete the square. And this is what it looks like. This is how you complete the square. So this also helps you figure out your vertices. Okay, so let's try solving this and try converting this standard form to a vertex form. Okay, so our product, to figure out what our, like to make the perfect square, x squared minus 8x plus what will be our perfect square, it's going to be 2 times negative 4. Negative 4 whole square is 16. So if I add 16 to this equation, to balance it out, I'll have to subtract 16 as well, right? So that's what I'll do. I'll add 16, 5, and y is equal to x squared minus 8x plus 16 minus 16 plus 5. Does that make sense? The reason why I added 16 is because I wanted to complete the square, make it into my vertex form. So if you compare your vertex form, you have x squared, ax squared plus bx plus c. And then for your vertex form, you have ax minus p squared plus q. You have this thing that the standard form is missing. It has x squared just next to a. It's missing the 2 terms being added or subtracted and square. So this is what we are trying to do with completing the square essentially. Does that make sense? So when I do this, I know it's going to be a perfect square, and what will my factors be if I were to convert it into a equal binomial factor? If I were to factor this, what will I get? My product is,
you have 2 and 4, I think, right? Or negative 2 and 4?
4 and 4. Sum is negative 8. Products is 16. So your factors will be negative 4 comma negative 4. That means you'll have this as your square trinomial. Okay. and the negative 16 plus 5 will be on the side. X minus 4 squared minus 16 plus 5 is minus 11, and that's my vertex form.
Why did you subtract 16 and add 5 at the end?
Because they're like terms. The reason why I subtracted 16 is because if I add 16, I have to subtract 16 to still have the same equation. Like, let's say I'm saying y is equal to 5 apples. And if I add y is equal to 5 apples, and I add bananas to it, this was my original equation. If I add bananas, it is a whole new equation, y2. But if I want to keep it as y1, I'll have to subtract b so that I still have my original equation.
And then what about the 5?
5 was from here.
Oh, okay.
The only confusing step for this is completing the square, this piece. Adding, subtracting, and completing the square. So let's look at the steps to solve this. First of all, we'll write the given question in standard form. Then we will divide our b value by 2. So our b value is 8 over here. Square it, add and subtract it. Okay, so what they mean over here is we are going to divide our b value by 2, which is how we got 4, right? Do 4 square it, which was 16. Add and subtract it, okay? And then multiply subtracted value by a. And bring it outside the bracket. So in this case, our a value was 1, right? So we multiplied 16 with 1, which just gave us 16. And then we are going to factor our perfect square trinomial, which was this step right here. Step 1 was this, step 2 happened here, step 3 also happened here, step 4, factoring it, happened here. God bless you. Are we good? Questions?
On the test, will it or on the blueprint, will it, or the formula sheet, will it say what vertex form looks like?
Yeah.
Okay.
It'll just have it. It won't say vertex form or standard form. It'll just have the forms.
Yeah, and A.
Yeah.
Okay.
Okay, let's move on. So if you want to check if we did this properly or not, what we can do is we can either sub in value for x and solve for y. So in this case, like when you put that there, you will have y equal for the standard form and the vertex form, and graphically graph both into y1, y2, and it should give you the same graph. Okay. We can also look at that when we do the next question here. the previous question we did had the leading coefficient of 1. What if the leading coefficient is not 1? What we will try is we'll try to make our equation with the leading coefficient of 1. So how can we do that? If we look at this, can we factor out something over here? -2, which will give me x squared plus 8x minus 15, right? After that, I just need to complete my squares. So the step was that I do b divided by 2, which will give me 4, do the square of that, which is 16, add and subtract that. So -2 x squared plus 8x plus 16 minus 16, which potentially is 0, right? And now this is our perfect trinomial, right? But this thing needs to go out. To take it out, we first need to multiply it with -2, right? Which will give us -2 x squared plus 8x plus 16 minus 2 times minus 16 minus 15. So I'm just breaking my terms down. I'm splitting this and the second term from each other, okay? So this is going to be, what would it be as a perfect trinomial, perfect square trinomial? Do you guys know how to factor it? Product sum factor?
4
X plus 4 square. Awesome. This will be -2 times minus 16 will be plus 32 minus 15. Our like terms, add them. We will get -2x plus 4 square plus 17 as our vertex form. Okay. So everything from here were the same steps that we did for our leading coefficient 1. The only step that was added was factor out the greatest common factor, or the coefficient in this case, of the first two terms. And then repeat the same steps. Yes.
Do you always take just like, so it's like where it's like -2x squared plus 8x plus 16 minus 16? Do you always just take whatever the last one is? Like, would minus 16 always be the one you would take, or like the minus you always one you would take? One that you have to subtract, or would you sometimes take the one that you have to ask? Like into the.
But they're the same numbers.
Yeah.
Oh, like factor them out?
Yeah.
Yes. We'll always take away the one that's negative. Because when we expand, like let's say we have x minus 1 times x minus 1, right? That would still give us a positive value. So x squared minus x minus x plus 1, which will be x squared minus 2x plus 1. If I had x plus 1 times x plus 1, I would still have a plus over here. So let's try that again. X squared times plus x plus another x plus 1. So I'll have x squared plus 2x plus 1. So you can have a negative in your b value, negative or positive, but your c value usually is positive. Okay, let's try checking our work with what we know here. Okay, so let's sub in a value for x. Let's say over here x is 1, -2, 1 square, minus 16, 1 minus 15, and we are trying to find our y value. So it'll be -2 minus 16 minus 15, which will be negative 33. This should be the same for this as well. If I put x is equal to 1 in my vertex form, it should still give me the same answer for y. So let's try it. 1 plus 4 squared plus 17, negative 2 times 5 squared plus 17. Negative 2 times 25 is negative 50 plus 17 is negative 33. So that means I did do it right. That's how you can check your work on the test. That's one way of checking your work. The second way is
What if you substitute x for the first time you did that?
same, x is equal to 1.
What happened to the plus 4 in that first one?
Well, this was the standard form that I chose. And then,
Oh, you went from the very start of it.
yeah, so I'm just trying to check if I did this right or not. So I put the same value of x in both my standard and vertex form to figure out if I'll get the same value of y. And if I do, I did it right. The second way is using graphs. So what I want you to do is take your graphing calculators, put y1 is equal to this, and y2 is equal to our vertex form, and check if they overlap on each other or not. If they do, we did it right. If not, then there is some mistake that we made.
And then if they overlap, they're the same, but we already checked, so they're all the same. I'm just for the plot. Get it? Because it's a plot. I'm too sick. Get it for chapter 6. You're too sick. And too sick. We can talk about, bro. Like you're too sick to do this. Like we're sick, like or you're too sick to do this.
It's like that.
I realized that. Why didn't we try to use those videos? No one texted and I was like, nah, I'm not. They're moving faster. Like, oh,
Your things need to flow on batteries, by the way.
Thank you for letting me know. Okay, did it work?
For me,
It worked?
Yes.
Okay. So I'll give you guys a few minutes to just do part A over here. Once you're done with that, we will move on to the rest of the lesson. So when we factor, it is 3x squared plus 6x minus 7, because the greatest common factor of 3 and 18 is 3. Now you divide 6 by 2, which gives you 3. 3 squared is 9, so you add and subtract 9. 3x squared plus 6x plus 9 minus 9 minus 7. This will give you a perfect square trinomial, but you'll have to factor or get rid of the negative 9. So you do 3x squared plus 6x plus 9 minus 3 times 9 minus 7. So this is going to be x plus 3 squared times 3 minus 27 minus 7, which is equal to 3 times x plus 3 squared minus 34. And that's your answer. For the next one, because the leading coefficient is 1, you'll have to just find the find what your value of c would be. So you divide this by 2, you get negative 4 whole square is 16. So you do x squared minus 8x plus 16 minus 16 plus 5. This is a perfect square. Minus 16 plus 5 is negative 11. The product sum factor of this would be x minus 4 squared minus 11, and that's your answer. Okay, awesome. So just remember, when you look at a vertex form, what all do they tell you looking at a vertex form? What are the key information you get from there?
the vertex
the vertex P comma Q. You also find the axis of symmetry, right? P is equal to the axis of symmetry. And then Q is either the max or min at Y. Okay. And when you look at the standard form, what does it give us? Yeah.
I know the C in the standard form is
C is y-intercept. Okay. So that's just a summary. We have done this before in the previous lessons. So let's try analyzing or graphing a function when a quadratic function is given to us in standard form. So looking at the standard form, what do I know? Standard form tells us
That's not what I thought you meant. The line
okay, y-intercept 0, 5. Okay, now we're going to convert this into vertex form. My leading coefficient, always check my leading coefficient is 3, not equal to 1. So I have to factor it out. X squared plus 2x plus 5. Now I'll complete the square. What will, my b value is 2. I'll have to divide it, which gives me 1. 1 square is 1. So 3 times x squared plus 2x plus 1 minus 1. Oops. Plus 5. So this is what I'm going for, my perfect square binomial. I'll have to get rid of this. So I'll do 3x squared plus 2x plus 1 minus, plus 3, actually, minus 3 works. Minus 3 times 1 plus 5. You can also do plus 3 times minus 1. Either way, you'll get the same answer, okay? So this, what will my product sum factor give me? What factors will I have? Yeah, x plus 1 whole square minus 3 plus 5. Minus 3 plus 5 is plus 2. And that's my vertex form. Based on this, what is my A value? 3. That means vertical stretch by 3, right? My P value is
Did you say P?
no. What's the P value?
Oh, sorry,
Negative 1. Yeah, don't make that mistake. So that means we have a horizontal translation left by 1 unit. And then we have our Q, which is 2. Vertical translation up or down? Up by 2 units. Okay. Make sense? Our point will be negative 1, 2 as our vertex. So our vertex is negative 1, 2. Axis of symmetry will be
axis symmetry will be -1.
yes, x is equal to negative 1. Your minimum or maximum value will be? Is it minimum or will it be maximum? Is it going up or is it going down? Up, because this is positive, right? A is positive. So we'll have a min or max? Min. Your x and y-intercept will be? We know our y-intercept already, 0, 5, right? And what about our x-intercept? How can we find our x-intercept? Yeah, if y is equal to 0, right? In this case, there aren't any x-intercept. So let's draw it. Negative 1, 2. And then we have 0, 5. And because it's one space apart, we can have the same point over here as well. Let's graph it. Oops. Awesome. And we don't have any x-intercepts. Our domain will be x such that x ER, because all the values of x are available, and y will be y such that, God bless you,
Equal to or greater than?
good, 5, 2, because it's over here, right? 2 and above, y ER. Okay, awesome, that's it.